Okay, we're going to go over the study guide here for sections 3.1, 3.2, and 3.5. Once again, we're going to cover this in class mostly, but we are going to be just basically doing everything that we're going to see on the quiz on Friday. So without much being said, at any time, if you want to try any of these on your own, just make sure to pause the video or try this whole thing on your own. And check your work after you get done with it. Okay. First one here says evaluate f of x at the desired element. So f of x is equal to negative 3x plus 4. They give us x is equal to 3 and x is equal to 6. I'm going to go ahead and hit the focus button and see if I can get this to be a little more clear. All right. Now, since we have two of them here, we see x equals 3 and x equals 6, or x is 3 and 6. Basically, that just means we have to do the process twice. So we're going to have to do f of 3, which is going to cover the first one, and then we're going to have to do f of 6. Okay. If there's only one number, we would do one, but since we have two here, we're going to go ahead and just do both of them. All that means, though, is remember, each number we're going to be plugging in everywhere that we see an x. So this is going to be negative 3 times 3 plus 4, which is going to give us negative 3 times 3, which is negative 9 plus 4, which is going to give us negative 5 for f of 3 there. And we would do a very similar process for f of 6, just plugging it in. So negative 3 times 6 plus 4, we end up with negative 3 times 6 is negative 18. Add 4 to that to give us negative 14 for f of 6. Okay. All right, now let's look at the rest of this here. Is this a function or not? We have to determine what this is a function of. Now remember, first one's always our domain, the second one's always our range. How we determine if we have a function or not is we don't have any x's repeat. So once again, since we're dealing with the two circles here, obviously if we have a set of coordinate points, we just look at all the x's to see if they repeat. If we have a coordinate grid, we would see if we have two x's on a vertical line, or 2 points on a vertical line, which would mean x's repeat. Here we have to look to see if any of these have more than one line. So 2 only has one, the 4 only has one. Right here, 5 has 2 lines going off of it, meaning we have the points 5, 3 and 5, 2. Okay, so to determine if this is a function or not, this is not a function. Okay, but even though it's not a function, we can still define the domain and range. Now remember, the domain is the first circle. Okay, these are our x values. The range is the second circle, our y values. Okay, so to list the domain here, we would just list 2, 4, 5, 6. I have to do my squiggly brackets. Okay, and the range will be the second one here: 4, 3, 5, 2, and 0. Okay, remember, if we're dealing with coordinate points, we don't normally see numbers repeat too much here because they have the arrows going off of them. But when we're doing coordinate points, we only want to make sure that if we have some numbers repeat, we only write them down once. Now you'll notice that we have another example where it's asking if this is a function or not, domain and range, but look what they give us. They don't give us numbers this time. Now they're giving us terms. But it's elements, okay? They're all elements. Just like all these were elements, these are all elements. So we still need to see, for this given example, does everything in my first circle, which is my domain, have only one line? Chicago has one, New York has one, Las Vegas has one, and Connecticut has one. So yes, this is a function because they only have one line coming off of them, and we still would list our domain as all the elements in the domain circle. Okay, that would be Chicago, that would be New York, would be Las Vegas, and Connecticut. And the range is still the elements in our other circle here, which we have Tigers, Cardinals, Marlins, and Pioneers. Okay, it doesn't really matter if it's numbers or terms. Same process is going to be dealt with here. Okay. Now we have this bottom one here. Are either of these graphs functions? Now we don't have individual points here where we can see, can we draw a vertical line? But we still use the vertical line test. Okay? Still use the vertical line test. And remember, what that means is there anywhere on here, in this first graph, that I can draw a vertical line and hit more than one point? Now, the thing here with this graph that we have, right here is the only place where I can actually only hit one point. Because if I draw a line here, it's going to hit here and here. If I draw another one here, it's going to hit here and here. So we're going to have more than one location. So right here is enough for us to determine by using a vertical line that, hey, it hits more than one time, okay? So graph A is not a function, okay? No. This one, on the other hand, this M graph here, or W if you're looking at it upside down, okay? I'll get this focus up here. There we go. All right. And if I move my vertical line throughout the whole process, it never hits the graph more than once. It only hits one time. Okay? Only hits one time the whole time. So that means graph B would be our function in this case. Okay? All right. So that's the first page. We're going to flip it over to the bottom, the second page here. And I'm actually going to throw in a little bit of a curveball here just to see who all is doing the extra credit here to watch the video. At the top of the page here, what I want you to do is I want you to draw the 3 types of scatter plot trends that we can have. Okay? Draw the 3 types of scatter plot trends. Okay? So we're going to have positive, negative, and no. Okay? I want you guys to do that. So in order to get the extra credit this week, what you have to do is have this at the top of the back page and have it filled in correctly. Okay? Throw a little bit of a curveball in and see if we're able to follow the instructions. Okay? All right. So make sure you not only write that like right now. I'm not going to fill that in until maybe the end of the video just to show, but once again, actually, you know what? I believe we did a good job with this right now. I want to make sure you guys are able to study this a little bit. Go ahead and make sure you look at your notes if you can't remember, because they're right in there of what a positive trend, negative trend, and no trend look like. All right, which of the following of these are functions? We have 4 sets of coordinate points, and we have to determine which ones are functions or not. Okay? Remember, our functions don't have any x values that repeat. So we look at the x values in this first set. We have, if we want to, we can go ahead and underline all of them real quick. I have 4, 5, 5, and 6, which we see right there off the bat, or in the middle here, we have 5 and 5 that repeats, so that can't be 1. Let's go down here to this one. We have 1, 2, 3, and 4. All those are different, okay? So there's our answer, but I didn't put it on here, but just to make sure, sometimes they might say select all that apply, so let's go ahead and check the rest of these real quick. This one here, my x's are 1, 2, and 4. Notice those are all different, so C is also a function. So let's check this last one here real quick. Negative 6, 4, 5, 4, and negative 6, 3. Okay. We notice here that the x's do repeat on the first and last point, so there's not a function right there. Okay. Now, there's a little bit of a side question here. Are these 3 points linear? Okay. Now, how we would test if these 3 points are linear, we would need to bring out our Desmos calculator. Okay, Desmos calculator, get a table, and put these points in it. So our table is x1, y1, okay? So then we'd have the points negative 6, 4, 5, 4, and negative 6, 3, okay? Now, in order for these 3 points to be linear, when we plug these in, and then for our second equation, we do that y sub 1 is squiggle to mx sub 1 plus b. Remember, we have to look at the r squared and the r, okay? In order for this to be linear, the r squared and the r both have to be 1. If anything else, it's not going to be linear, okay? But if we go to plot those 3 points on there and we put it in our equation and r squared and r are both 1, then we do have a linear function. When we plug these 3 points in on our table, this is not linear, okay? Because we don't end up with r squared and r being 1 in this case, okay? Now, while we have the Desmos calculator out, we can look at the fill in the table one here, okay? We're going to look at the fill in the table one here, and we are going to basically just do all the work that we have here, okay? Now, I'm going to go ahead and move over here real quick, and I'm going to bring up the table, which I know you can't see. I don't think you can, but I'll find out, I guess, when we upload the video. And I'm going to bring up the Desmos calculator, okay? So, on the Desmos calculator, once again, we go to the table, and all we need to do is the one table needs to have an x. The other table needs to say x plus 4 quantity squared. All right, and then all I would need to do is type in the numbers that they're giving us there, which is 8, 9, 10, and 11. Okay? Once again, using the Desmos calculator is easy. Otherwise, you can plug it in. You plug in 8 here, you're going to get 8 plus 4, which is 12. And then you'd square the 12 to get 144. Okay, and you can continue that. If you plug in 9 here, we should be getting 169. If you plug in 10, we should be getting 196. And if you plug in 11, we should be getting 225. Okay, and we can do those by hand, or we can continue to use the Desmos calculator. And I'm going to go ahead and guess that we definitely want to use the Desmos calculator for the second one here because it's a little bit challenging of a equation looking there. Okay, so we're going to go ahead and type in that equation, which is 14 times the absolute value, which we have to go down to our table at the bottom of our page here, absolute value of x minus 2. All right. Then we got to go ahead and enter our values in, which is 6, 8, 14, and thanks to someone yesterday when I asked them to give me a number, 1 million. Okay? Now when we plug in 6 into this one, we get 6 minus 2, which is 4, and then 4 times 14 is 56. Okay, we can do that by hand, or we can use the table, especially to get these other values. Because when we plug in 8, we're going to get 84. When we plug in 14, we get 168. And when we plug in 1 million, we get 1.39 times 10 to the 7th power. A very big number there. Okay? Once again, make sure we're using Desmos calculator there to help ourselves out on problems such as this. Okay? Remember, when you use the Desmos calculator for these, you want to make sure that we change x1 to x and change y1 to the equation that we want to use. Okay, the last one's here. Which point is nonlinear with the following function? Now, they give us a function here, okay? All we need to do is put these points into our table and see if we have any of these points don't work, okay? Because it says what point is nonlinear with the following function. So I would go back to my Desmos calculator, okay? I would basically just go ahead and delete that table, start a new one, because we want the x1, y1 in this case. My x's that we have here are 2, 3, 4, and 5, and the y's that we have here are 135, 231, 359, and 519, okay? Now, if I go ahead and put my little my equation in, the y1 is squiggly to mx1 plus b. Oh, hold on one second. Did I enter one of those numbers in wrong? 135, 231, 359, 519. Darn, I think I did enter one of those wrong. Okay, the reason why I know I entered one of them wrong is because we do not end up with a linear function there. So what I'm going to do real quick, just to change this real quick, let me go ahead and take those out. Let me change this to just something different here. Well, okay, what are my values again? 2, 3, 4, and 5. Okay, go ahead and change that to x here. Okay, 2, 135. Plug in 2 to get 135. Okay, well, here's how we do this. You're not going to be able to see it on the video anyways. What we would do is we plot these points on a coordinate grid and then plug in our equation. Again, where that equation being y1 squiggle mx of 1 plus b. Okay, and when we do that, we get r squared and r to equal 1. Here's what you would need to do next. You would need to add each of these points individually. Okay, when we add those points individually, we are going to end up with r squared still equal to 1 and r is equal to 1 if it's linear. Now there is one of these 4 points, when we plug it in, it's going to give us something other than 1. I'm going to try to figure out real quick, if I can, I'm not going to be able to probably off the top of my head, what equation I use to get those. Okay? Actually, yes I can. If I did that again as an x1, maybe, x1, y1, I did that table again, what we had here, 135, 231, 359, 519. Okay. I don't know what points I exactly used there. Crazy. There's an error on my part there. Okay. Did I use maybe 1, 2, let's see. 1, 2, 3, 1, 2, 3, 4. No, did I use 3, 4, 5, 6? No, 4, 5, 6, 7, 7, 8. No. No. Well, that's unfortunate. So I'm out here to fix this one here at the end. But once again, what I'm saying here at the end here, if we have a problem like this, which we will, okay, we'd plug this table in, and then we would put our equation in. We'd end up with r squared is equal to 1, r is equal to 1 for that linear table. Once again, all we have to do is add this point in, 11, 21, 51, and if these are still 1, then that means that point is on this line. Then I would take that point out, we add this point, all right? And then we still end up with r squared is equal to 1 and r is equal to 1. One of these 4 points, when you go to plug it in, it's going to make these ones change, okay? Now, if I'm not mistaken, if I remember when I did this yesterday, this is the one that should have, when we plugged it in, not worked, okay? So maybe what I can do, just to try to fix myself here, maybe I can, maybe I accidentally put those points in wrong, but what I'll do here is I'll plug in my other choices. 11, 21, 51, you're seeing me here trying to figure out backwards math here. 3399, 3399. Maybe those were it right there. Let me see what happens now when I do 2, 3, 4, 5. Okay. So now my equation I want to use is 416 minus 2425. 416x minus 2425. Take that x value out. Man, I didn't get that one though. Crazy. Not sure what I did there. It's a little bit unfortunate. Okay. But either way though, guys, on that one, remember, as long as we put our table in, we're going to end up with this being 1, 1 here. We're going to add in these points individually. So if you have any questions, we'll go over this in class today to make sure you guys are clear on it. All right. All right, that's going to conclude the study guide today. Make sure, I will mention something about a bonus problem, so make sure you remember, or you go back in the video if you didn't recall that. If you guys do have any questions before the quiz, though, as always, email me.